with a quick video on some ideas that are in your textbook at the bottom of page 95. And the questions in there have to do with if you do some manipulation with polynomials, is your answer still a polynomial? So in order to be able to answer those questions, we have to first understand what a polynomial is. So when we look at this definition, it says a polynomial function of x is a function given by a sum of terms. Okay, so we're going to have several terms together, each of which is a constant times a whole number power of x. A constant times a whole number power of x. And then the word polynomial is used to refer both to the function and to the expression defining it. So those parts that I highlighted, a sum of terms, each of which is a constant times a whole number power of x. We're going to be doing some work with polynomials and see if our new answers fit that definition. So here's our first example. We're going to be adding these two polynomials and see if you add or subtract two polynomials, will you always get a polynomial? So when you're adding polynomials, it's just a matter of combining the like terms. So when I look at my two polynomials here, I notice that there's two polynomials. Each one is in a set of parentheses, and I'm adding them together. So I can simply remove the parentheses and then look for like terms. That's plus 7x to the fourth, and then plus 5x to the third, and plus 24. Okay, so I have two things I want to accomplish at this point. I want to write my answer with the highest power of x coming first, and then also be thinking about combining like terms. So I notice this plus 7x to the fourth doesn't have a like term, and it is the highest power of x. So we have 7x to the fourth, and then we have two terms that have x to the third. So 4x to the third and plus 5x to the third. So that's positive or plus 9x to the third altogether. All right, and now we look for the next power of x would be squared. There's a minus 3x squared, and it doesn't have a like term, so that would come next. And then we have plus 10 and plus 24. Both are constants. They add up to 34 altogether. And so we have just added two polynomials. Our resulting expression is also a polynomial because it is a sum of terms that are a constant times a whole number power of x. A constant times a whole number power of x. Now we're going to move to the next slide, which we have an example of subtraction. So same kind of idea as what we were doing before, only that when we remove the parentheses between or around each polynomial, we have to pay attention to the fact that there's a minus in the middle. So each of the terms after it are then going to have the opposite sign. So when we remove the first set of parentheses, the polynomial remains the same, 9x to the third plus 7x squared minus 11x. But in the second set, all of those signs will change. So we have minus 6x to the fourth plus 2x to the third and minus 4x squared. So again, same as last time, we're going to be combining like terms and then also making our answer come from the highest power of the variable down to the lowest. And so the minus 6x to the fourth, there isn't a like term for that, but it will come first in our answer. And then we have two terms that have x to the third. And their total is positive 11x to the third. We have plus 7x squared and minus 4x squared for a total of plus 3x squared. And then the last term here is minus 11x. So once again, our resulting expression is a polynomial. It is the sum of terms that are a constant times a whole number power of x. So those whole number powers of x in order are the power of 4, that's a whole number, the power of 3, another whole number, the power of 2, which is a whole number, and the last one has an implied power of 1, also a whole number. So this certainly fits our definition of polynomial. So to answer the question, if you add or subtract two polynomials, will you always get a polynomial? The answer is yes. On the last slide I have here is going to answer the second question in your textbook from page 95. If you multiply two polynomials, will you always get a polynomial? So when I multiply polynomials such as the one shown, I usually use a box. And so I line the sides of the box with the expression. So this first one has 3 terms, so I'm going to write each term separately across the top. And then x squared minus 9, I'm going to put that down the side. And then inside each box, I will put the product of the left and the top of that box. So for the first box, x squared times 5x to the third is 5x to the fifth. And then below it, negative 9 times 5x to the third is negative 45x to the third. And make that 3 a little bit better. Okay, and then x squared times negative 7x squared is negative 7x to the fourth. And negative 7x squared times negative 9 is positive 63x squared. And in the last column, 2x times x squared is 2x to the third. And below that, 2x times negative 9 is negative 18x. So then to write out my answer after multiplying, I'm going to look through and see if I have any like terms. I see negative 45x to the third and 2x to the third. Those are like terms. And the rest of the terms don't have a like term within the solution. So I'm going to write it out in order from the highest power of x to the lowest. So 5x to the fifth minus 7x to the fourth minus 43x to the third and plus 63x squared and minus 18x. All right, so once again, the expression that I got after multiplying is also a polynomial. It is a sum of terms with a constant times a whole number power of x. And you can see that in the 5 terms shown there in the solution. And so if you multiply two polynomials, will you always get a polynomial? The answer is yes. So I hope this review of adding, subtracting, and multiplying polynomials was helpful and that you